Thank you everybody for being here today. As Peter mentioned, we're going to be trying to get a better understanding of what limitations are there. We're going to look at what is in the code today. The code is under review constantly, so this might change. Please keep in mind, we're going to focus on products that are already tested and certified, okay? We'll go through basic components, the different test standards, and we're going to go through several examples and best practices at the end. We're going to finish with a case study together with NADA to better understand the concepts explained and make sure that with an actual situation, it's hypothetical, but goes through the documentation and what is needed. So to get started, we're going to be focusing on reaction to fire. As Peter mentioned at the beginning, and NADA as well, this is the contribution of a material to the fire growth, to how the material itself will react in the case of fire. We have several criteria like combustibility, heat release, toxicity, flame propagation. And when assessing fire performance, we'll always have material and components versus system and assemblies. So today we will be focusing on material and components, though in the case study we will also include a system or an assembly test as necessary. So just very quickly, what are the UAE Code requirements for facade components? This is just a very quick table. We have different sections for different products: ACP, EIFS, polycarbonate, sandwich panels, and GRC and GRP. So we see that in the UAE Code, there are many different methods depending on the product. So today we'll go through all of them with the exception of for sandwich panels. Even though this is in the facade section of the code, the requirements that require these two test methods for sandwich panels, they are not for exterior walls. So we're not gonna look at them today, okay? So we're gonna start with the most common, EN 13501-1. NADA did go through it, she explained it very well. So we're just going to focus on the limitations, okay? What we need to look at when we have a submittal on a product and how it was tested and if we can use it for our project, okay? Also for manufacturers, what they need to test to make sure that they cover what they're going to go after in projects. So number one, let's start. 13501-1 is a fire classification method. So within that standard, you will have the classifications for wall, ceiling, and floor applications, okay? So the results are applicable when tested vertically. The results are applicable for vertical and ceiling positions of the product. When you need to, the final use of the product is as a floor, you need different tests. So how do you differentiate? So you need to make sure that if we're going to use in a wall, we go for a classification that is for walls. In this case, it will be, as always, a letter, S, and subindex, and then the D for the droplets and the number. If it has a subindex of FL, that means that the testing was for floors only, and it is not applicable for a vertical external facade. Then we also have 13501-5. This is the classification for roofs. Why am I mentioning this in exterior walls? Because we're in the Middle East. And here you'll find facades, very unique, unbelievable projects. So like in this photo, you have this facade that goes and turns into a roof. And then even here on the inside, in the entrance, you could consider this to be as a floor, okay? So in this case, if a product is only tested as a wall, you should consider before accepting this product. You need to make sure you have the full compliance, and as such, it is reflected in the code. So here it says where the building envelope is uniquely shaped and designed, and it turns into the roof, you need to test it as a roof, okay? So in general, for vertical facades, you need to make sure it's EN 13501-1 and that it was classified in the vertical orientation. Today, moving forward, the most common one is 13501-1 in the vertical orientation. So we're going to focus on the requirements of this. So joints. This is applicable for panels, any system that has joints. So within 13501-1, depending on what classification you're going for, different test methods are required. So with this in mind, any topic I mention, at the beginning, we're going to mention what limitations are applicable to. So for example, for A1, I will mention specifically when the limitations apply to that. But most of them will see joints, air gaps do apply only to A2, B, C, and D classified products, okay? So this is one of those cases. So for joints, we need to keep in mind that it cannot be installed with joints unless it was tested with joints, okay? The standard is very clear on that. So we have we've seen some products tested without joints. They tend to perform a lot better, okay? So always keep in mind, vertical joints, it needs to be tested with vertical joints if you want both, or either you need to test with it, okay? To ensure that the test assembly represents the final use. So one thing that's important, if joints have any additional components like sealants, they must be tested with it, okay? They should not be applied on site if they have not been tested with it. In examples, we'll see how you find out if they've been tested with it or not. Another thing is the air gap. Again, this is only applicable to classifications that require the SBI, A2, B, C, and D. So again, if it has an air gap, it needs to be tested with an air gap. These limitations will also be included at the end, so you should just look for that information. It is very important because when there's an air gap, there's oxygen coming from both sides, so that can, depending on the product, but that can affect the results significantly. Okay, you'll see if it's tested with a 40 mm air gap, you can use it with any size of air gap. If it's tested with 80 mm, it's self-supporting. Okay, any other size gap, the results are applicable to that size only. Okay, so keep that in mind. If you have a product that is applicable only to a 20 mm and in the project it has 40 mm, it should not be used based on those test results. Okay, you need to. We'll see what you can do, ask for further documentation from the manufacturer or different options that are included in the code. Again, another thing very important, thickness. Okay, this will come up in other methods. But the more material there is or the less, the performance in fire is expected to change, okay? So this is applicable to all classification. The thickness of a product and its layers, they can greatly affect the results. So always make sure that the thickness you're installing on site matches within the allowances of the tested and the certified range. Again, color and finish. People don't realize color and finish can have a great effect in the fire performance. Again, this applies to all classifications, no matter if it's A1 to F, all of them. Okay, they can greatly affect the results. There is standardized criteria to cover a range of colors. Okay, so don't think you need to test every single option to cover a full range. But that standardized criteria needs to be met. Okay, so the test results are only applicable to the color and finish specified. This will also include matte finish. Different options of finish that will also affect the results. And lastly, we have the substrate. Okay, this substrate is applicable only to A2 through D classifications. The substrate you test with will limit where you can apply the product. Okay, so make sure you always on site is installed as per the limitations of that specific product. Again, the substrate can be standardized, so wood, steel, gypsum boards, fiber cement boards, etc. There are many, many options. So in the code, we find 13501-1. As we mentioned, this is a fire classification method. Okay, so within that, again, we're focusing on vertical. You'll find 4 different test methods. Okay, so depending on the classification, different tests will be required. So just wanted to mention, as per the code, this would be the general requirement that you will find here. This is a small typo. It should say A1. So it's either A1 or A2. Okay, the tests required for A1 are these 2 at the bottom, 1716 and 1182, okay, with some very unique exceptions. So here you should focus mostly on 13501-1 and the requirements, okay? because sometimes this is not applicable in this case. So for A1, we said these standards are not needed. For A2, the SBI is required, but this one is not necessary. Okay, and just to mention, just so that in the future, you open the code, you open the submittal, and it doesn't match. There is a small typo here. It should be -2, and that's it. Okay. So now, as we said, we're going to look at an example. Okay. So here we have a public listing. This is public information that is available to anyone. So this is a 13501-1. Okay, so first of all, the thickness. It needs to be specified. We mentioned the thickness of a product is a key aspect of it. Second thing we'll find, color and finish. Okay, this is in no specific order. You'll find it like this as long as the information is there and you can find it, that's good enough. Color and finish are a limitation. The orientation, so we can see that it's 13501-1 and the classification doesn't have any sub-index. So this is only applicable for vertical walls, okay? Now, and ceiling. Okay, and now we mentioned joints, air gap, and substrate. So you will find it here, okay? The phrasing can be different, but the important thing is that all the information is there available. Okay, again, this standard, I'm not gonna mention it. As I said, it's not applicable to facades, okay? It's only applicable to internal non-fire resistance rated walls made of sandwich panels. So it's not the case, we won't go too much into them. Now we're going to cover E84 and UL 723. Now I already explained what it is, it's a standard tunnel, you have a ceiling position, and you are evaluating the surface burning characteristics of building materials, okay? So you have two parameters, the flame spread index and the smoke development index. You'll find that they're always multiples of 5, that's not by chance. It's part of the standard, you round it up to 5, so you will always see that. Okay, now in the UAE Code, the requirement is Class A, which is an SDI under 450 and FSI under 25. Now this classification does not come from the standard. Class A in the standard does not exist. This classification comes from the IBC. Okay, in the UAE Code, what they've done is they specified what Class A means. Okay, so it's the same requirements. Now, important about the ASTM 84, the results are only applicable to the specific product and thickness specified, okay? As we said, the thickness is key, look for it. It's not orientation specific in this case. So any product where you want to assess the surface burning characteristics, you will test in a ceiling position. And one thing that is important for non-symmetrical components is the side of exposure, okay? Do keep an eye out for that. If it's non-symmetrical, it should be mentioned, okay, in the documentation, and it should be applied as such. Now in ASTM E84, there's no consideration for only ceiling position results for materials that melt and drip, okay, such as thermoplastic materials. We have a standard that is very similar to E84, but does take this into consideration. This will be UL 723. Okay, so the big question, what is the difference between ASTM E84 and UL 723? So the standards themselves are pretty similar. So you have your ceiling position, your flame, 10-minute test, and you see how far you track the smoke and the flame spread, okay? You calculate areas, and that will give you the values that you need. But the key difference here is, in UL 723, when a material drips and falls into the floor, here they call it floor ignition occurs, okay? So the moment floor ignition occurs, so that is considered one test. So from the beginning, you have your test begins. If there's ignition on the floor, it can be in minute 2, minute 3, or second 15. Whenever it happens, you have one result for that time. Okay, that is the only on ceiling position. Since the test duration is not the complete 10 minutes, you tend to get lower results. Okay, so this classification is only for the ceiling. The other classification, we'll see an example now, will be your standard ASTM E84 test results. So when a material does not drip or fall into the floor of the standard tunnel, you'll find that the classification and everything is identical with both methods. Okay, so as such, the applicability and results, what we mentioned about E84, is going to be the same. Thickness, site of exposure. So here we have an example. We mentioned the thickness. And here we have the UL723 results. Here we have 25 or less and 450. In this specific listing, there's no class A was enough, so only those results are displayed. But at the bottom, you can see that the flame spread and the smoke developed. According, okay, it was 90 and 850, okay, because that is the full result for the 10 minutes. That would be the result you would obtain from an E84 test. But in this case, since UL723 has that option of classifying with only the time the material remains in the ceiling, you get that other classification, okay? So you should always get both results. When you look at UL723, if you don't get two results, it's because it's not a dripping material and they're the same. And here another example. So this is for E84 directly. You have the thickness and your results, okay? One thing that is important in, you'll see here, we mentioned to ensure consistency of results, 3 tests. Why do I mention this? Because we're talking about reaction to fire. To make a quick comparison between the European and the astm E84, well, the key one is ASTM E84 and UL723, they only measure 2 parameters, okay? 13501-1 measures a lot more. But in general, the EN method requires several tests to complete classification, okay? So you want consistency. This is not a requirement in E84. So to ensure consistency, we do strongly advise that at least 3 tests are carried out, okay? So we usually do 3, but you'll find out there all sorts of situations. We try and be consistent. If the EN method requires 3, for E84 as well, okay? And one last thing, A1 or A2 in the EN method have nothing to do with class A in E84 or the UL723, okay? They look similar, but they have nothing to do. A product could be both at the same time, but being one does absolutely not entail achieving, if you're class A in ASTM E84, it does not entail achieving A1 or A2 in the EN method. Now we're going to go very quickly over ASTM D1929. So just what I wanted to mention here, the applicability of this standard is for plastics, but in the UAE Code, it's required for other products, non-plastic products. So for example, sandwich panels, if they're Roku, they should have this method as well. Okay, GRC is not a plastic, glass reinforced concrete. You need to test it. So it's done, okay, but it's not within the, it's done only in the Middle East. You will find it, but the standard is not designed for that kind of product. And lastly, to mention, you will see always as the results, FIT and SIT, okay, flash ignition temperature or spontaneous ignition temperature. These are the 2 results given in this method. The UAE Code talks about a self-ignition temperature, okay, of over 343, okay? What do they mean? This is equivalent to the spontaneous ignition temperature, okay? So if you're ever given the results, you need to look at the SIT to make sure that, to look for the self-ignition temperature. So a quick example here, see, you have the method and the different temperatures for both values of the same product. This standard is mentioned as well in the table for GRCs and GRPs. One thing to keep in mind, this is not applicable to GRCs. This is a product standard, basically. This is the standard specification for glass fiber reinforced polyester plastic panels. So what that means is GRC, this would never be applicable. The requirements in the code are CC1 and CC2. Just know CC1, limited flammability, CC2, general purpose, okay? The methods themselves to obtain either one or the other would be your standard American. You have D1929, you have E84 here that we've discussed already. And lastly, of these standards that we're going to discuss is NFPA 268. So I mentioned at the beginning we would focus mostly on components, but this is the case where the standard is for the system you're going to install. This is a requirement for each system. So in here, this is a test where it's applicable only to flat facades, okay, and all layers are assembled together. You're not testing the individual components, you're testing a panel made of all the different layers. It needs to be tested as in final use, okay? And that is important. Make sure that the thicknesses, as we mentioned, the coatings, the types and colors of render system, they are as tested because they can affect the results. We're going to be talking about radiant heat. This is a test for radiant heat. This is a radiant panel. So smoke is okay, but there's no flame can appear. Okay, so very quickly, best practice here. Do understand the limitations on the applicability of results. Always check the full description in the certification directory, okay? In the UAE, we're lucky. It's mandatory that all certification bodies have all this information publicly available. For example, in Europe, this is not mandatory. In the Middle East, it is. So use that tool because it's going to come in it's going to be very useful. One thing, don't rely on test reports, okay? We're talking about systems. Sometimes one system is based on 50 test reports. So don't focus on that. That job has been done already by the certification body. Focus on that deliverable, the COC or the directory, okay? That assessment has been made. In case of inconsistencies, always ask the supplier or reach out to the certification body for clarification when needed, okay? And lastly, as we mentioned, there's a couple of typos in the code. Just make sure you read the code in conjunction with the standard so that if there are any typos, you can detect them, okay, and not reject a product because, an issue like this. Okay, so now we're gonna go through a case study. Nara has been nice enough to let us use one of her company's systems to use as a case study here. So I'm gonna have her join me in case. Nara, are you with us?
Me?
Yeah.
Okay, perfect.
Okay, so in case she has anything to add. Okay, so case study. Okay, we're going to focus very quickly on fire performance only. Facade systems are complex systems, but to make sure that what we discussed earlier, we can see a full example, we'll just focus on that. So we have a project where we need a facade system. An eave system for a non-load bearing and non-fire resistant exterior wall in a mid-rise building. Insulation is required. So we go to the code and we check the minimum requirement. So here we have all components need to be tested to E84 and B class A. The panel as a product, so it needs to be tested to NFPA 268. And the wall assembly can be tested to either one of these 4 test methods. Okay, so these are the requirements. So we get a system submitted. It's an eave system. This is an example. We have the supporting wall, your channels and studs, okay, backboard, adhesive, insulation, and your render system. With this submittal, they provide civil defense product approval and certification seals. That's where you will find the more detailed information. So this is what they submit, okay? So they submit, basically this is the public information I've included here. Okay, so for the system, they submit an NFPA 285, NFPA 268, okay, for the system, and then the different components, tested to ASTM 84, class A, the thickness is here. One of the components, the rock wool, they submit a different manufacturer certification for E84, a different certification body, sorry. This would be the case, no problem, as long as they're approved. You'll find the other components here. I mean, this is a summarized version. Of course, they submit a lot more paperwork, but here is all that we need to look at for now. So this, for the assembly test, okay, thickness and result is not good enough. You need to have a good understanding of what is covered, okay? So an assembly test will come with the details of what is covered by those tests. So this would be the case. Here they talk, it's mentioned about the thicknesses, the densities, everything that is covered in this case. So first step, they've submitted this ASTM 84. We checked that it meets the UAE Code standard and minimum class. Okay, so all the products match. They're all compliant. In this case, out of the 4, they provided NFPA 25. Okay, great. Now, we're going to talk about the system they've submitted, okay, the details. Please keep in mind that the submittal system that I'm going to mention right now has been absolutely made up to support the learning in this study, okay? So this does not reflect an actual submittal in any way. It's just I made things on purpose to make sure that some key points that I discussed were addressed. So going through the previous documentation, all the details, I've done all that legwork for you. So I have here that these documents cover these products, okay? So basically, sheeting board, adhesive, the stone wool in this case, base coat, we have the mesh, the primer, the top coat, and then the system, okay? That cover all the above in these specific thicknesses, okay, and products. And if there are any other limitations, I've added them here. For example, even though the products that they have submitted for E84 for the mineral wool here is a full range of thicknesses and densities, our results for the assembly test don't cover the same range. They don't have to. We just need to make sure that they overlap with what was submitted. Okay, so that's what we're going to look at. So sheeting board, check, same thing. Here we have a mortar of 4 mm, and they submitted a 3 mm mortar. So it's not matching what they submitted with the product covered by the documentation because of the thickness. We have the 84. They've submitted 40 mm slabs with 180 density. This is covered, no problem, by the E84. Again, same thing with the base coat, the mesh, the primer, the top coat. They all match. Okay, this is good. Now, we look at the products covered are this. But there are some limitations on the NFPA 268 and NFPA 285 on what stone wool can be used for these results to be applicable. So the minimum thickness of the stone wool needs to be 50 mm on both. And as you see here, they submitted a 40 mm thick. So it's not matching, okay? The stone wool that they've submitted for the project does not match with what they have done. Now, what can we do? First of all, always ask the supplier first. Maybe they do have the evidence, they have it right, you know. If you're working with reputable manufacturers, they usually have long list of different certifications, so they might have it. But if that is not available, possible action, you know, included in the UAE Code. Ask the supplier to get the needs of the project included in their certification. Okay, they know, they reach out to the certification body. The certification body will tell them what they need to do to include it. Letter report of findings by experts. You have engineering judgments as well. These are done by a certification body, fire consultant, or the fire protection engineer, like it says in the code. One option always is also do a custom task specific for the project, you know, if none of the above can be done. And last option, you know, is always there, reject the submitted system because it's not compliant with the code. So just to close up, what would we advise in this case? So we were talking about a 3 mm, 4 mm, you know, it's a 1 mm difference. You still have to reject it in the initial stage, but either ask the supplier to provide evidence for 3 mm or change the system to 4 mm. You know, the moment they apply 4 mm thickness, you would be okay. Here, what can you do in this case for the system plan? Either include it in the COC, so the manufacturer or the supplier would go to the certification body and update it. You can get an engineering judgment or a custom test. Okay, these usually, you know, is sort of in order of resources required to make the system compliant. So there are options. There are always options. Okay, so talk to the supplier, and a solution can always be found. Okay, so with this, Nada, anything you want to add?
No, Chris. Thank you.